Hi, in this tutorial, I will review question number 1 from chapter 2. So, which basically asks how to find central moments if you have the survey data. So, our data consists of 13 observations, and we need to find central moments like mean, median, variance, standard deviation, skewness, and kurtosis. Let's start with the mean. To find out the mean, we need to sum all the data in the sample and divide the result by the sample size. So sample size is 13, so we sum up the data and we get 21. So that's the mean, sample mean. To find out the median, we need to rank the data, which is already done. So data is already ranked, and we need to find out the middle data point in the sample. So we have 13 data points. So 7th place in the sample should be the median, and which is 22. So that we have 6 observations left to 22 and 6 observations left to 22. So, and that's the median, 22. Let's look up the what's the population variance and sample variance. So in order to find either of those two, we need to first calculate a total sum of squares, which is the sum of all squared deviations of each data point from the data mean. So data mean is 21, so we are finding deviation from first observation, which is 5 minus 21, raising into power 2, and continuing to do that for every data point in the sample. Then we sum up everything, we get 1,408, and then in order to find the population variance, we are dividing 1,408 by 13, which turns out to be 108.31, and in order to find sample variance, we need to divide by 1,408 by n minus 1, so which is 12. So that gives us 117.33. To find out the population standard deviation, we are taking the square root from the population variance, and to find out the sample standard deviation, we are taking the square root from the sample variance. Now, in order to find out the skewness, we need to rely on the following formula. So 1 divided over n, sum of all xi minus mu divided by sigma. We treat mu to be 21 and the sigma to be 10.41. Sigma denotes the population standard deviation, and mu stands for the mean, okay, population mean. So we find out those standardized deviations, we raise into power 3, we sum them up, and we divide the result by 13, and we get negative 1.20 divided by 13, coming out to be negative 0.09. Now, what does it mean to have the negative skewness? So skewness can be either positive number and or 0 or negative number, and the magnitude can be any magnitude indeed. So what does it mean now to have on the first place positive, 0 or negative, and how the magnitude, what magnitude indicates? So that we can see on the following figures here. So on the first graph, you see negatively skewed distribution. So negatively skewed, like example we are just reviewing, is negatively skewed, which means what? It's more likely to have large deviations from the mean on the left-hand side rather than on the right-hand side. So on the right-hand side of the data, above mean, data are more concentrated, close proximity of the mean. But on the left-hand side, deviation is much larger. That's why we get negatively skewed data. In case when we get the 0 skewed, that means that data is symmetric around the mean. And in case of positively skewed, the variation of data on the above mean is much larger than on the left-hand side. So on the left-hand side, data are more focused around the mean, but on the right-hand side, you have a very high likely that sample data can be too large too far from the mean. That's the indication of the positive skews. So positive skewness. And when magnitudes are very large and negative, that means that the tail is too high on the left-hand side. And if it's positively skewed and skewness is very large, that means the tail of the distribution is very high on the right-hand side. Okay, now let's find out what's the kurtosis. So you remember on the when we found out the skewness, we standardized the data points by subtracting mean and dividing by the standard deviation, and then raised into power 3. But now we will raise that standardized observations into power 4. So we want to find out how large are deviations from the mean. So if the kurtosis is very large number, that means that you get the data in the sample which are too far away from the mean. So basically kurtosis indicates that tail weights, okay, whether distribution is light tail or heavy tail. Okay, so anything which is around 3 is called the normal distribution or mesokurtic distribution. So, and this is indicated by the green line. If you have kurtosis less than 3, that's the placokurtic distribution, which indicates that most of the data are concentrated around the mean, and the tails are very light, very unlikely to have large deviations from the mean. In case of leptokurtic distribution, which is indicated by the red line, you have some data, of course, are concentrated around the mean, but the likelihood to get large deviations is very likely as well. And this is known as a heavy tail distribution, and usually arises in finance and in the returns, in investment returns. Okay, that basically summarizes the question number 1 from chapter 2.